Energy. The term energy refers to the ability to do work. The SI unit of energy is joule. Forms of energy. We have two major forms of energy: the kinetic energy and potential energy. Kinetic energy. Kinetic energy is the energy possessed by a body in motion. Mathematically, kinetic energy is equal to mv squared over 2, where m is the mass of the body and v is the velocity or the speed of the body in motion. By definition, potential energy is the energy possessed by a body due to its position or state relative to others. Mathematically, potential energy is mgh, where m is the mass, g is the acceleration due to gravity acting on the body, and h is the height at which the body is, or the position of the body. Now let's look at energy conservation. Energy conservation. Energy can neither be created nor destroyed. So as this body is here, energy is conserved, no energy is lost. So at these points, potential energy is maximum. The body at this height is having maximum potential energy but zero kinetic energy. So as this body moves down, let's say at these points, no energy is lost. Just that the potential energy will decrease a little bit and the kinetic energy will start increasing, since the body is now in motion. But in all, no energy is lost. As this body moves down and about to hit the ground, just before it hits the ground, the potential energy at this point will be zero, but the kinetic energy will be maximum. So you can say that the initial energy here is equal to the final energy. So the potential energy at this point will be totally transformed into kinetic energy.
We have this example: a body of mass 0.6 kg is thrown vertically upward from the ground with a speed of 20 meters per second. Calculate its potential energy at the maximum height reached. Then the kinetic energy just before it hits the ground. Now let us see how we can solve this question. So we are trying to find the potential energy at the maximum height reached. So potential energy at maximum height reached, PE, is equal to mass times gravity due to acceleration times height. And we were given the mass from the question to be 0.6 kg. Then also we know that the gravity due to acceleration is equal to 10 meters per second squared. Now we don't know the height yet, but the maximum height reached on projection is given by h equal u squared over 2g. So we just do the substitution. The initial velocity is 20 meters per second. So 20 squared over 2 times 10, which is the gravity due to acceleration, and this will give us 400 over 20, which simplifies to 20 meters. Hence our height is 20 meters. So we can substitute into PE is equal to mgh to get 0.6 times 10 times the height, which is 20 meters, and that will give us 6 times 20, and that will be equal to 120 joules. Now the B part, kinetic energy just before it hits the ground. So we saw earlier that kinetic energy just before the object hit the ground is equal to the potential energy at maximum height reached. So this means that the kinetic energy just before it hits the ground will be equal to the potential energy that we had, which is equal to 120 joules. Here is another example. A body of mass 20 kg falls from the height of 10 meters. If g equals 10.0 meters per second square, calculate the velocity of the body just before it touches the ground. So let's see how we solve this question. We know that we can use this equation, or we've seen earlier that the kinetic energy just before the ball touches the ground will be equal to the potential energy at maximum. So we can use the equation, that is, we equate the two equations for potential energy and kinetic energy. So this will give us half mv squared is equal to mgh. So m is common to both sides, so we can cancel, then multiply both sides by 2 to get v squared. V squared is equal to 2gh. Now we can take the positive square root of both sides to get v is equal to square root of 2gh. So we just have to substitute g equal 20 kg and h is equal to 10 meters times 2. So that will give us v equal square root of 2 times 10 times 2 times 10 times h. The h is also 10. So that will be equal to 2 times 10 times 10, which is equal to square root of 200. So we take square root of 200 to obtain approximately 14.0 meters per second. 14.0 meters per second. So therefore the correct answer will be equal to option B. we have this example here. A body of mass 20 grams projected vertically upwards in a vacuum returns to the point of projection after 1.2 seconds. So we were given gravity due to acceleration to be 10 meters per second squared. Determine the potential energy of the body at the maximum height of its motion. So let us see whether we can use some diagram to explain the question before we start a solution. So we have this over here. Let this be the body with mass 20 grams. Then when we project it upwards, vertically upwards, now it will go up like this, and it has reached the maximum height over here. So we have this to be our height, which is h over here. Now we were told that the body returns to the point of projection after 1.2 seconds. So it has come down. So the total time taken is 1.2 seconds. 1.2 seconds. Now we need to use the fact that, so this is 1.2 seconds. We need to use the fact that the time taken to reach the maximum height is equal to the time taken to return to the point of projection. So it means in each of them we have 0.6 seconds. Now what we do next is to calculate the potential energy of the body at the maximum height of its motion. But we know that we are going to use the fact that the kinetic energy on projection of this body is equal to the potential energy at maximum height. So we have the kinetic energy. So Ke is equal to half mv squared. So from the question we have the mass, which is m, to be equal to 20 grams. We need to convert this to kilograms. So when we do that, we obtain the mass to be equal to 0.02 kg. 0.02 kg. Now we need to determine the speed that we don't have, and we can use an equation from motion, which is v equal u minus gt. V equal u minus gt, since the projection is vertically upwards. Now over here, which is the maximum point, the final velocity is 0 in this case. So we substitute the time 0.6 and the gravity due to acceleration, which is given in the question as 10. So we get 0 equal u minus 10 times 0.6 seconds, and this will give us 0 is equal to u minus 6, because 10 times 0.6 is 6. This implies that our speed is equal to 6. So this u is equal to the speed, which is v, and that is what we need to continue over here. So the u here is the speed here. So we substitute, and we also substitute the mass in kilogram to obtain the kinetic energy to be equal to half of the mass, which is 0.02 times 6 squared. So we need to simplify this to obtain half of 0.02 times 36. 0.02 times 36. And when we simplify this, we obtain 0.36 joules. So the correct answer is option A.